So now we'll try to look at the stream analytics competition that has been provided here. So this is the description of the competition, and this is the overview of the competition page currently and how it works, registered for the competition, and then let's try to discuss about the problem statement here. So objective of the statement problem statement is to create the create a streaming based network anomaly detection application using Stream Analytics platform. They have been provided They have provided a network dataset collected of raw TCP dump for a local area networks. So problem statement says that determine the possible abnormal network activities characterized by data points from the network data characteristics. So we have been provided training dataset and prediction dataset. So it says that examine the dataset, identify the parameters on which anomaly could be determined, use the training dataset to model the online real-time learning algorithm, applying the model on prediction dataset to identify the anomalies if any. So now let's try to look at the data dictionary here. So these are among like 43 fields that have been provided, where you can clearly see that there are some continuous variables and there are some discrete variables. So let's try to look at the data set currently. I have downloaded data set into my system. Um, so you can look at the training sample.csv. This is a CSV file with the header that has been provided. So if you can take a closer look at of this data dictionary, you can all that you find is from the field number 1 to 44 with the different descriptions here, like duration, number of bytes from the source, number of destination bytes, number of wrong fragments, number of root connection, number of shell connections, whether it's a hot login or whether it's a guest login, like etc. etc. There are almost like 43 parameters. Along with these 43 parameters, you do have an extra parameter called as an IP address from which this particular connection has been established. So when you clearly see at this training sample, there is no field, or there is in ideal kind of data science, we have two kinds of algorithms, wherein which there is a supervised model and unsupervised model. Supervised model is something wherein which in the training data set you are provided a label. It's a labeled data set where you have been provided a list of items, and then you have a predefined label which says whether it's which classifies the particular data point. But you don't have such label here. So every record here doesn't, any of the label here doesn't say that whether particular record is an anomaly or if it's not an anomaly. So when it is being told that it's the training sample, we without any label, we need to assume that the only option we have is to go ahead with the unsupervised learning and assume that every data point over here provided in this training data sample.csv is like not an anomaly. So let's try to look at this data set. I'm comfortable in R. I would like to explore this training sample.csv in R. So let's get on to the RStudio here. So you can see I've read this training sample.csv here into a data frame, and then you can look at the observations here. So even though if there are some discrete, there have been a lot of them, a lot of the fields have been normalized and provided to you. And also the discrete variables are mostly having the values of 0 or 1. So I would like to, when you go for anomaly detection, the only solution that comes into my mind is to prepare a clustering wherein which plot these training data sets into different clusters and identify a new data point which is very far from every other cluster as an anomaly. We do have some algorithm. The random normally like algorithms used for anomaly detection or like first basic algorithm used is k-means clustering. There are also like other complex algorithm like multivariate Gaussian distribution wherein you point the each label in a graph. Like I'll try to show you. Um, Multivariate GAU Gaussian distribution in anomaly detection. This is from Andrew Ng, multivariate. This is a best excellent course from Andrew Ng for this, which explains about how can you detect an anomaly using multivariate Gaussian distribution. But the only problem we have is we don't have a pre-built mechanism of running this multivariate Gaussian distribution in Spark or the Stream Analytics platform. So I would go with a simple Stream Analytics, K-means clustering. So the problem which we have with K-means clustering is you need to specify the fixed number of clusters well before you run the K-means. So the best way to identify the K-means clustering, like I mean to say the number of clusters you need to train the model for K-means is to plot them as a dendrogram. So I would like to remove the IP address. So I have made the IP as a null. So currently I would like to take all the data points into my model. So I have calculated the distance using Euclidean. Euclidean is a distance between 2 points in a multi-dimensional space. So you are calculating the distance between each point, and then you are trying to fetch the hierarchical clustering package, and then I'm plotting the hierarchical cluster package here. If you can closely see this, this is a very wide data set about the data points. At a very high level, you have 2 clusters. If you drill down a step down, you have like 3 clusters. You can drill down further, you have like 1, 2, 3, 4 clusters. And if you go far down, I would say I would have like 6 clusters. I would expect like to divide this based on 6 clusters. So let's try to make this into like a 6 clusters. So I would like to make this as like 6 clusters. So let's see if there is a red line being plotted onto our dendrogram. I would expect this to be divided into 6 plots. I'd like to refresh this plot again. Not sure what's going on in my system over here. Probably is lacking the RAM, or I don't know. So let's go back here, plot the fit again. See? Okay. Still under a plot. Okay, plot was successful. But where is my plot here? Okay. Okay, you got this dendrogram over here. So based on this dendrogram, I would like to decide about having a 6 clusters. I would like to give one more last try here, and if it doesn't work, decide on having a 6 clusters. Okay, well, I'm like not sure why. Yeah, there you go. So we got the borders of 6 clusters, wherein which it is dividing the entire clusters into 6 here. So let's try to use this diagram as a base picture of analysis of this data science competition, and then let's go ahead and run the k-means clustering.